All right, so tonight we have Stuart Batty demonstrating for us. He's going to do a volcano bowl, which is a little bit of an advanced turning. But Stuart is local. He lives up in Boulder. He has his own tool line. He has a wood turning school that just opened up. It is fabulous. It's fantastic. And he's got so many years of experience. And in my opinion, I think he's one of the best educators around as far as wood turning goes. And it's honestly a great honor that he is here and that he's local too, so that he's close by and that he can come to our club and do a demo for us. So if you want to take it away with what you're going to do
Thanks.
tonight, go right ahead.
Thanks, Jess. And thanks to her help because she helped me carry all the tools down on the conveyor and the grinder in and everything. She just get going with it. It's like, yeah. So if I'd taken another 20 seconds, I wouldn't even have to touch them. But because she carried them down so quick. So thanks to Jessica for that. Thanks for being here tonight. I'm not a member of any wood turning club because wood turning is my profession, not my hobby. So I love wood turning. I'm passionate about it, but I don't ever think of going to turn something for fun. If I'm not getting paid, I'm not turning. Does that make sense? So, and I've been turning a long time. So I've been turning now for 50 years. So, and I've been a professional for 44 years. And I have demonstrated at almost all the wood turning countries in the world. And so I've been fortunate enough to have met all the big names in wood turners and worked alongside them. My first ever symposium I did, I was 17. I was just about to turn 18, and I was demonstrating alongside some old guys. They were at least 40. Yeah. So anyway, there was Richard Rappin, Ray Key, and Bert Marsh. Now, if you've been in wood turning a while, you know who they are, but if you haven't, you won't know who they were. But at the time, I was a serious production turner. Everything was about the faster I could make it, the more money I made. But they were more artistic, and they'd come from different backgrounds. Like Richard Rappin was a wine merchant, Mick O'Donnell was a painter, and Ray Key was a pattern maker, but I was the production turner. So I didn't know what it was expected of me to do a demo. And so my first ever demo is I made a bowl and sanded and finished it. And then I made an 18-inch goblet, 1/8 of an inch long, sanded and finished it in an hour and a half, thinking that was normal. And then Richard Raffin says, "What the hell were you doing?" I says, "Turning." He says, "We're supposed to explain what you're doing." I'm like, "Really?" Oh, like they could see what I was doing. Anyway, since then I've become more of an educator. So my background is production spindle turning. My dad, my granddad were production spindle turners. They did apprenticeships. I did an apprenticeship. So I went through the learning sequence that my dad did. But one thing I've changed because I worked for my dad as I did my apprenticeship, and I'd already been turning a long time, is I have seriously modernized wood turning. Now, everybody can end up making a bowl, but the way I make a bowl is very fast. I don't ever deal with torn grain ever, and I don't use physical strength. So I just use leverage, I use technique, but my style is tricky to learn because it is skill based. It isn't about, you know, beating the crap out the wood or getting beaten up on the lathe and then sanding the hell out of it. The sanding I'm doing is just to remove tool marks. So when I'm sanding, I am not reshaping the bowl. I am not taking away torn grain. I'm taking away tool marks, and everybody has tool marks because we are human after all. We're not robots. And even if a robot made a bowl, it would still leave tool marks because you were cutting a continuous spiral. And so you're just trying to take that out. So a lot of the things that you've heard of and know of in wood turning have come from me turning and teaching for the last I've actually been turning 50 years this month, and I've been teaching this month 44 years. So I developed a lot of just unique little tips and techniques and tools that you know of and heard of that use, and I'll go over those today because what I'm going to do is as Jessica said, it is an advanced project. This is not a project to do if you have not turned a lot of regular bowls. The risk factor on this would be astronomical if you are not at least familiar with the gouge, because I'm going to be turning a block of wood like this, and it's got corners, and the potential for things to go wrong are significantly higher. It's one thing for a round bowl to come off the lathe. It's a different story when it's got corners. So, and we don't turn it at a crazy fast speed, and we want to get the mass down. And I do a lot of things to keep me safe and make sure it doesn't come off the lathe. But it isn't without risk, as in, is there a defect in the piece of wood and it could pull apart? Could I neglect to forget to tighten the tailstock? Something like that. So for certain cuts, I'll be putting on the face shield. If I was just spindle turning or doing a simple round bowl, I likely wouldn't wear a face shield. But for this, you would definitely have to wear a face shield. And if you do want to try one of these, just start off with a little 4-inch block because that's going to be trouble enough as it is. This block here, and I'm going to give you an option. Do you want me to do a nice big rectangular one like this, or do you want me to do with 2 bark edges? So it doesn't make no difference because they're about the same size. Bark. Okay. Might slow me down by about 30 seconds. Right. Because I got to keep the bark on. Right. Okay. And then, so my background, as I said, was spindle turning. So in spindle turning, I did a lot of what are called, we call them balustrades and newel posts. You guys will know them as stair spindles. So cutting pommels is something I was very familiar with. A pommel is where you cut through a corner, square corner, to leave it clean, to mate with a round surface. And basically, a square bowl, a wing bowl, and a rectangular bowl is a lot of pommel cutting. And so because I did it as a kid, I'm very familiar. And the advantage that I had over my dad with pommels was I never cut pommels with a skew. And I know my dad did in every generation for hundreds of years, cut it with a skew, and people still cut them with a skew. But there's a huge advantage in doing it with a gouge. A gouge is faster, cleaner, easier to control, much safer. And I'm taking that exact same gouge that I ground, which was a 40/40. I developed it specifically for cutting pommels, and I use it on a bowl and for a lot of other applications. So some of you have heard of the 40/40. It's basically a very fast, effective way of cutting. And the reason it's different from any other grind, the Irish grind or whatever else somebody else does, it's the only tool in wood turning history that can take a large volume directly to a sandable surface. There is no other tool that can take a large volume that doesn't need reworking with a finer cut before you can sand it. It's the only one ever. And I developed it for the specific purpose of cutting a pommel. In fact, I'll do one right now. In fact, let's do on a short block here because we'll concentrate on the bowl. And pommel cutting was something that I didn't know at the time as a kid, was developing really good skill. And so in a class when I teach, and next week I'm teaching a class in Boulder, the students will have to turn pommels for at least maybe an hour, and they will learn how to control the gouge. Because we've all heard the saying where people say, rub the bevel, find the bevel, put pressure on it. That is actually complete fabrication. If you are rubbing the bevel, you are turning badly. Did you know that? It is impossible to rub the bevel and cut a pommel. It's impossible to cut that square bowl if you're rubbing the bevel. The professionals that say they're rubbing the bevel are not rubbing the bevel. It's BS. The bevel is touching the surface, but there is zero physical weight on that bevel. If you put weight on that bevel, it is impossible to cut a pommel. Now, can you cut a round circle or go across end grain with rubbing the bevel? Sure, but it's just going to start bouncing. So who's had the bounce when they've been cutting? You're going like, oh, I'm on the bevel, and all of a sudden it starts bouncing. It's because the bevel starts to interact with the surface. So think of it like an ice skate. It's just gliding on top of the surface. But if you put any energy, and that energy will always come from your left hand. Your right hand can't put pressure on the bevel. And so my style of turning is 100% when I'm turning with a gouge, right hand control, left hand assistance. It's really important to remember it is not a two-handed cut. We're not rowing like rowing in a boat. We're not pull cutting like Mike Mahoney or David Ellsworth that are using 2 hands. We're using 1 hand and the bevel and a correctly sharpened tool, and then it's fast, it's simple, and it doesn't take much energy at all. And if you're getting any vibration back to your body from cutting, then your cutting is wrong. That means you are either rubbing the bevel or you're off the bevel. Now, we do need to use the bevel. The bevel does several things for us. It gives us tool control, and it protects the cutting edge. And what I mean by protects the cutting edge, your edge will last significantly longer if you're on the bevel than if you're completely off it. If you're completely off it, your tool is dulling 30 times faster than if you use the bevel correctly. So I'll demonstrate the pommel. And like I said, this is a technique I learned as a kid, but I learned it as a skew. And I said to my dad, I used to work with my dad he used to pay me, for 40 hours a week. And I says, can I change the way I work for you? Because I'm broke. Can you pay me by the piece? And my dad laughed at me and he says, now you're really going to be broke. And I says, hell no, I'm going to get fast. And I got fast because I changed the way we turned. We were not turning well. We were using very bad ergonomics. This is the book my dad used to talk about, is his little Bible. This is written, actually was, I thought it was written in the year I was born, but it actually, the reprint of this one was 65. I was born in 65. It was actually written in 1958. And my dad called it the Bible. And you know what this book is? Garbage. Oh, sorry, my bad. It's garbage. You know why it's garbage? The ergonomics this guy is using is terrible. He must have been really sore after every day of turning. Every chip he ever turns hits his left hand. His arm is up in the air all day long, and his shoulders, rotator cuffs under tension, and he never once mentions where he puts his feet. I mean, it's a book on how to turn, and he doesn't tell you where to put your feet. Where you put your feet is critical to turning. And his bull gouge has a handle of 9 inches, right? Tell me what's wrong with that picture of this bull gouge with a 9-inch handle right here. He's a freaking wood turner. Why doesn't he make a 24-inch handle? That's what he does for a living. He makes spindles, just turn a longer handle. So I don't get it. This was the gouge I grew up with. It was hideous. And I remember saying to Sobeys, because I worked for Sobeys, because I lived in Sheffield, and I says, can you make this modular and make it longer? And you know what they said to me? Can't tell us what to do. You're just a wood turner. We're the engineers. Go to engineering school and then tell us how to make it. And then I says, you do know somebody one day is going to make a modular handle that's longer and better. And he says, no, we're the biggest supplier in the world. We supply everybody. And then all of a sudden, make a real wood turning tool. That's what you turn a gouge with. At least 24, a bowl with, at least 24 inches. You female turners out there, you can't turn with a 16-inch handle. If you watch on the video, some videos online, when somebody's turning with a 16-inch handle, watch them do the bowl dance, where the gouge is doing this the whole way around. You've got no leverage. Now, I don't need leverage for a pommel, because a pommel is tiny. So for that, I can get away with just using any length handle. Doesn't really matter, because I'm only going to be off the tool rest a tiny bit. Now, this is a 40-40 grind. I'll draw on the board what it looks like in a minute. But basically, what I need to do is to remove a lot of waste, and I need to be able to get a great finish, because on a pommel, they were never sanded. Think about the pommel. It's a square section. If you were to sand it, you would damage it. So it had to be cut as clean as possible without sanding it. And therefore, and remember, if you see newel posts or stair spindles in the UK, they could be 150 years old. So people are going to walk past it for a very long time. So it has to be clean and it has to look good. So let's turn a pommel, and then I'll pass this around and you can see. Now, taking this lathe up to the higher speed. In my school, we use all Powermatics. So Powermatics are great lathe. I mean, there's Lagunas out there. Lagunas might in somewhat seem like better value, but they are not as nice to use as a Powermatic. I know you got your American Beauties out there, but this being all cast iron, it really does help. So it's really good with harmonics, and the electronics on this are good. And I love that you can move this guy, which I'm going to take advantage of that when I turn the square bowl, because I want my controls on this side of the bowl, not on the opposite, so I don't reach through the corners. But for now, we're good. Okay, so pommel, let's get fired up. Now, you need speed. Not crazy fast, but it'll sound faster than it is just because it's going to be moving air. So this is a time where this is not a hand rest. You guys put your hand on this rest all the time, don't you? If you put your hand on this rest, you are screwing your cut. It's only a guide if you're doing a straight line. Otherwise, don't touch it. You touch it on an entry cut, and then you move your hand back. It is not a hand rest. My dad called it a hand rest. He calls it a hand rest. It is not a hand rest. It's for your tool. So when I do the cut here, I don't want to touch the tool rest at all. It's impossible to do a perfect pommel if you touch the tool rest with your hand. So you start slightly away and you just lean into the cut. And all I'm doing is using my body to lean. I'm not using my arms. I'm just leaning on my left leg, and I can cut this pommel. I just cut a pommel in 2 cuts. If I did that with a skew, how many cuts would I have taken with a skew chisel? Possibly at least 12. So 2 versus 12 versus I can't really get a catch with a gouge, but you can with a skew. And that is ready to sand. And that's all I did. Let's go the other way. So we're going the other way, and then I'll pass it around. And you'll see what we're looking for. So this cut here, because I'm right-handed, you could do it left-handed. That would be the same, but most of you guys are going to be doing it right-handed. I would just lean slightly. So instead of leaning this way, I'm going to put my feet parallel and lean the other way. It's still leaning. Just that foot's right where I want to put my foot. So I got to put my foot on the other side. And I want to get myself set up a bit like a golfer. When he's going to hit the ball, he doesn't just run over and smash into the ball. He gets set up. I'm setting myself up to not fail. So I'm getting myself positioned, comfortable. Now I can move with the gouge. So let's see you do it too. There's the first cut. Second cut slower. The slower I go, the better the finish. We're not in a rush to do the finish cut. We're in a rush to do all other cuts, but not the finish cut. The finish cut. Anytime in wood turning, you're having a problem, just slow the cut down. And that problem often just goes away. Often we're cutting too quickly and rushing. So you can see I've cut a pommel and I've cut a pommel. And by using the gouge exactly perpendicular, because it's got a 40-degree bevel, I end up with exactly the same pommel left and right, which you want them to be the same. And then to get into the corner, I'll just grab a roughing gouge. I didn't even unwrap it because I thought, I'm not going to use a roughing gouge. And then I forgot I'm going to use a roughing gouge. So spindle roughing gouge. Been around a long time. What did it used to be called? Roughing gouge. Actually, it used to be called a roughing out gouge. Then we called it a roughing gouge, and then now we call it a spindle roughing gouge. So why did it go from roughing out gouge to roughing gouge to spindle roughing gouge? Exactly. So I changed the name of this at the request of Craft Supplies 20 years ago. Daryl phones me up, Daryl Nish, he's the owner of Craft Supplies. He says, Stu, we replace over 100 of these a year, broken. I says, oh yeah, people use it on a bowl. He says, what do I do? I says, well, look, how many catalogs you print a year? He says, 250,000. I says, change the name in your catalog and it will become the normal name. Just call it a spindle roughing out gouge and tell somebody if they break it, you're not replacing it because you can't break it spindle turning. It would be virtually impossible to break it spindle turning, but you can break it instantly in wood turning. So I have a lot of videos online and they're all free. I don't sell any videos. And so if you just go to my website, there's at least 20 hours of videos. So you just put my name in, I'll spell it up here, just stuartbatty.com, that'll do. That's my name. Okay, and then on that, that'll give you at least 20 hours of videos on how to sharpen every tool and how to deep position, correct technique, and what have you. Where's it going? So I have 7 fundamentals. Number 1, grain direction. Number 2, chuck. In other words, you're chucking it correctly so you don't get hit by it. Number 3 is the tool must be sharp. Number 4 is tool rest, not a hand rest. Set the height, the distance. Number 5 is lathe speed. Fast enough to be a little bit scary, but not suicidal. You guys know the difference. All right. If you feel like super panicky in front of it, going like that's fast, then turn it down. But if you don't feel slightly threatened by it, it's not fast enough. So it is a little margin between the two. You want your heart rate not pounding, but you want to know it's clocking. Wood turning doesn't work at slow speed. We're not carving. It just doesn't work. In fact, you work harder if it's too slow. It's going to want to pull the tool in. You get more control. Why do some wood turners turn at crazy high speeds? I wasn't going to say the name, guys. Come on. Because it's actually easier. But for that extra 5%, 10% ease of cut, you quadruple the chance of getting seriously hurt. So you don't want to ever get hit by a piece of wood, right? And we wear face shields and what have you, but the face shield won't save you if the wood's doing 120 miles an hour. You just skip the ER room and they take you straight to the morgue. So that's not why you're wood turning. You guys aren't skydiving, bungee jumping, right? That's not your hobby. Your hobby is to make pieces of wood and not get clocked by them. Once in a while, it is definitely going to come off the lathe, guys. Somewhere you're going to make a mistake, defect in the wood. It doesn't matter. But you want to be able to walk away and go, man, that was scary. And maybe you've even got a thick lip. But you didn't end up in the ER room or worse. So remember, lathe speed is the outside maximum periphery speed, which you could work it out, but you don't need to, is 40 miles an hour if the piece of wood is perfect and perfectly balanced and your lathe is sturdy. Anything other than that, it's got to go down, down, down. Okay, and then the next is stance. Where do I put my feet? And then the 7th is technique. That's just how do I control the tool? But you have to get these somewhat right before you apply technique. So I got to know which direction the grain's running. You cut the wrong way in wood turning, it's called a catch. Anybody ever had a catch? I knew it. You were the first group that never had a catch. That's pretty impressive. So if you had a catch, what did you do? You you cut uphill into end grain with a sharp edge, and it will 100% catch 100% of the time. There is no way around it. So you had a sharp edge uphill, and the end grain will pull it down. A sharp edge uphill into side grain is how you cut. A sharp edge uphill into end grain, like on the side of a bowl and a spindle roughing gouge, will create a catch. Anyway, chucking is, remember, location, then we secure it. That's just something to remember there, because chucking there's a little bit more to chucking. I have a lot more videos on chucking than I do on almost anything else, because people get chucking wrong all the time, and you're already kind of somewhat screwed in the pieces flexing on the lathe before you get going. And then sharp tool. I've been turning now, like I said, 50 years. You give me a dull tool, I'm no better with a dull tool than you are. I sharpen a lot. So Marty's mentioned before he's got that sharpening class next week. If you can attend it, that's great. If you can sharpen correctly, you're already 90% of the way. And if you sharpen the tool correctly, I sharpen my tools to work for me. I don't own any tools that I work for because I own them. I don't know if you know that, but it's different to how some of you guys do like the Irish grind. If you do the Irish grind, you're working for that gouge. That gouge ain't working for you. I promise you. I went to Andrew Pierce Bowls. They're the biggest bowl factory in the USA. They make 50,000 bowls a year, just a few guys. When I went there, they're using the Irish grind. How many bowls a year did each one turn? Turning 40 hours a week. And they never did anything but turn. They didn't core them. They didn't even oil them. They didn't sign them. They just took a cord blank that was dry, did the inside and the outside, like a couple of cuts on the inside, a couple of cuts on the outside. How many bowls a year do you think they were turning each when I got there? 1,500. 3 months later, how many were they turning a year? 8,250 each. How? I took away the torn grain. The Irish grind will not give you a good finish on dried wood. My cut works exactly the same on dry and wet. The only difference is the chips are hotter and it'll be a little bit more dusty. And you have to push a little harder because it's dry. That's why we don't rough turn dry blocks of wood. We rough turn wet blocks, let them dry, and then you only got to do a couple of cuts. Anyway, these I'm not going to go much over because it's not a techniques class because I'm going to make something. I've done a pommel. Let's just show you how a roughing gouge works. And yes, this roughing gouge is made by Henry Taylor, and yes, it sucks because they put the tang off center. So when you go into a corner, which it's meant to do because it's got sharp corners to go into a corner, it wants to pull itself in. But my roughing gouges that we're making, we don't have any left. So because we make gouges in Boulder, really high-tech new gouges, and I've only got 2 defective ones here because every time we make one, we've already sold it, and we're already like 6 weeks behind, so we just have to keep getting rid of them. So this cut's a square cut, so I stand square to the lathe, and I just cut into the corner with this guy, but this guy is fighting me. He wants to pull into the corner because Sorby's and Henry Taylor, and they're all in the same city of Sheffield, the British mentality is, can't tell an engineer how to make a tool unless you're an engineer. I mean, honestly, that was the truth. They said to me, well, did you go to engineering school, Stuart? You can tell us how to make a gadget. I said, I'm the one using it. Well, he said, we don't care. You can't tell us how to make something. We're engineers. It's this snobbery. Anyway, screw them. So make better tools here in Colorado. So that's 2 pummels. That's pummel cutting. So you don't have to sand it. So I'm going to apply some of that to making this wing bowl. Now, this is an on-center bowl, not off-center, but it does have wings, and I do need to remember, drop my speed, and you guys insisted on the one with the bark. It's going to slow me down. Okay, this is oak. I have no idea what kind of oak it is. It's very pretty, so it should look really nice in the end. I just got it out of, where was I the other day? Littleton. So this tree came out of Littleton, and a friend of mine's got a yard there, and he cut it down. So it's got a really nice, dark heart and sapwood. It's going to eat the hell out of the bed of the lathe. So we need to remember to wipe that down after because it'll oxidize the bed because this is cast iron. So like I said, I've been turning a long time. And working for my dad was it was challenging. My dad was I don't know. My dad was kind of stuck in his ways with how he turned. He's a big skew fan. My dad's got online. If you just type in Alan Batty, my dad's video will come up on how to use the skew. But here's the crazy thing about that video. He was so proud of that video. And I said, but it's all BS. He said, what do you mean it's all BS? I says, so you did a video for 2 hours on the skew, but when we did production turning, we didn't use the skew that much. What did we use? A beating and parting tool. But for some reason or other, it's kind of macho to say you use a skew and kind of cool because it's hard to use and it likes to catch and you look good when you use a skew. But to be truthful, gouges are better and a beading and parting tool is infinitely better at rolling a bead than a skew because you can't use a skew to make a balustrade. Did anybody know that? So where that pummel is, I can't use a skew to roll the bead where the pummel is because the skew's width and the angle it has to approach at will clip the corners. So we use a beading and parting tool, which is just a square little chisel. I've got one here. I don't know what the camera is. This little guy here. That's what we use to roll beads. Just that. The French use a badan. The English use a beading and parting tool. Why would you use something angled when you can go left and right with the same chisel and not have to angle it and it doesn't hit the pummel? So we never roll beads with a skew. And I see people do it all the time. I'm like, that's not how we turned it. That's not how the French do it. It's not how the British do it. But then all of a sudden, it's like cool to use a skew. I'm just not a big skew fan because, like I said, it's great for certain jobs like cutting V's, negative rake scraper, can opener. It's got all these great uses, but it isn't the be all and end all for certain things. Okay, so what we've got here is we've got a square ball. It's pretty much on center. I've got a feeling I'm going to get a slight weight imbalance. I ignored the bark, but I'm slightly heavier to this side, but I'm still going to leave it on center. So we'll have to start slow. And what we need to do as quickly as possible is get the mass down. In fact, ideally, I'd like to get it on a chuck as quickly as possible. There's two ways of mounting this. If I'm really nervous about mounting stuff with students or myself, it's something that's a crazy piece. This is just the faceplate that came with this lathe. I just put some grade 8 bolts. They're the little cap head screws you can buy from Home Depot. Sharpened them on my grinder because you can sharpen hardened steel on CBN. You just can't grind regular steel or stainless steel on it. And then it just became a spiky little drive. And that works great for driving on if you're unsecure about, how much grip you've got. Because I can't mount this on a chuck straight away. I could put it on a screw chuck, but then I got to put a hole in it and I got to find a drill and et cetera, et cetera. And I still got to flatten the surface. But this is just little cheap faceplate. You can buy a faceplate anywhere. That fits inch quarter rate for probably $20. And then you've got a drive center here if you want to do it that way. So let's just do it that way. We know it's not going to come off. Okay. So like I said, I've been turning a long time, and through wood turning, I had the fortune of meeting Princess Diana. You guys heard of her? I think at the time she might have been the most famous person in the world at the time, because even people in Africa knew who Princess Diana was. But we change our prime minister so quick in England, I don't even know who the prime minister is. I mean, we just fire them like that. You guys can't fire your presidents, but we can. As soon as you screw up, like, gone. You guys get to keep them and recycle them and regurgitate them, and ours we just like, nah, you crap, you're gone. I love that about that. Yeah, just you're good, you're bad, go goodbye. But anyway, so through wood turning, I get to meet Princess Diana, and it was a big ruckus, of course, because I wasn't supposed to be there. Well, according to everybody else. So how it worked was, we have the British Arts Council in the UK, and for the first time ever, they were going to have this royal tent at Chatsworth House. Chatsworth House is big grounds owned by this wealthy, well, they weren't so wealthy at the time. I think they were burning more money than they were making. But anyway, it was part of the royal family. And so they're going to have a royal tent and about 20 other marquee tents where, you're regular artists, you got stuck in that tent. But if you got selected by the British Crafts Council, you got in the royal tent. But I'm only 21. And all these other people are like ancient, even possibly up to 50 years old. And we're in this tent and they were all like, what are you doing in here? I'm like, I didn't pick myself here, man. I just got selected. But so I was lucky to get in there. So I get to meet Princess Diana. But I remember this guy comes in the tent and he looks at me and he says, what, you're just getting out of diapers? I'm like, oh, I said, what's that for? He says, well, what are you doing in this tent? Look at everybody else. They're all mature. They're adults. You're just a kid. I says, I don't know, maybe I'm okay at wood turning. He said, and this guy was like furious that he wasn't there. I said, well, I'm sorry you're not here, but yeah, I said, you must be really good. So when I get a chance, I'll come look at your work in Marquee. Which one are you in? He's like, 24. Like, right, oh, that's bottom of the pile, but I didn't say that. Anyway, so I thought he must be really good. He's probably better than my dad. And I'm like, my dad was very good. So I'm thinking, this guy must be great. So anyway, I'm set up. The helicopter with Princess Diana's not coming in for a couple hours. I said to my girlfriend, hey, I'm just gonna check this guy out. Maybe he's like as good or better than my dad. So I go check him out, and he makes his bowls exactly like the bowl in this book. How did they used to make bowls? Why you never see a good bowl back in England back in the day? Why was there never any good bowls? And it doesn't make sense because we had jam chucking, but they made lousy bowls. How was it made? That makes it ugly and horrible. Screw holes in the bottom, and then and felt across it. So when I get to this guy's marquee, I look at his balls. It's 1/4 inch to the top, and I go to pick it up, and I need a forklift. And I'm like, oh, okay. I says, you should come see my work. And I said to him, it's just come check it out. I says, your work's good, but come see what I do. Because he had been working in isolation, didn't realize that I don't get it. They used to jam chuck. So why didn't he jam chuck and turn the base off? I mean, that's what I'm going to do with this bowl. I'm going to take these spike marks out by jam chucking it and turning them off. Anyway, so he says, I'll come along and look at your work after, royalties being there. So when he came along, my work was, I used to make really thin, really tall pieces. So 1/10 of an inch, and maybe it's up to 14 inches deep, super thin. So what did he say when he came over and looked at my work? What did he actually say? He apologized. He says, I didn't know you could turn like this level. He said, I thought this was impossible. So what did he actually do? He took a class. And he got good. He just didn't know. One of my apprentices, I have a number of apprentices. Apprentices are people that have worked me for quite a while, and then they end up teaching with me. So obviously, you've likely heard of Ashley Harwood, Cindy Drozda. I have a bunch of apprentices that come along, and so they get to super high level. But one of them is a guy called Steve Landau. You guys won't ever have heard of him. He just sells his work through a cooperative, and he helped me teach Andrew Pierce bowls. Those guys that went from 1,500 bowls to 8,000 each, he helped me teach them because he's that proficient. Anyway, he had been turning for 20 years, and then he saw me turn a bowl one time, and he says, whoa, I need to learn to turn like that. And so he came and took a class, and then he became phenomenal. Just turning 20 years, just making the same old Irish grind, tone grain, fighting itch, too short a handle, and then he improved. So we can all improve. So wood turning is definitely skill based, folks. There's no easy ride to it. You're not going to get great at wood turning overnight, but if you can get training, like I said, they've got mentor classes here. They've got people here that can do all the different grinds and can sharpen and can control the tools. It is wood turning because working in isolation is hard in wood turning. So I'm just being super safe here, paranoid, making sure everything's tight, 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 because this is a rectangle and I am going to wear safety glasses and I'm going to put this on to be sensible. Okay, and then the other thing I'm just going to check, because this is not my lathe, I'm just going to make sure the headstock is actually tight, okay, because it is a movable headstock. So, oh yeah. And I see that somebody's put a piece of paper in here, which I put it in there. And that's never been removed since. No chance, really? Wow, it must have worked then. That's a very expensive fix. You people might not see there's a piece of paper, it jammed in between there and there, and I put it in there, because was there some harmonics on it last time? Ah, oh, well, there you go. Oh, there you go. I honestly thought, wow, somebody's pinched my idea. Oh no, I didn't take it out. I just tore it off a bit. It was distracting. It's still there. Look, it's at the back. It was distracting me. Sorry. Right. I can't. Was anybody else use this lathe? Yes. I mean, I said, as I said to Jessica, this is the same lathe. It looks pretty new, but I know it only gets used once a month. So, she's always worried about. I am on a stage. Normally, I don't turn on a stage. Okay. Now, how fast can I turn this? Definitely not over 1,000, but I do need to get it a bit more balanced. So, I remember on a spike here, but it's a pretty good guarantee. There is no 100% guarantee. So I am not putting my face in front of it, not until I get the weight down. So I'm going to stand to the side. I have to put my arm on top for this cut. Normally I want my arm underneath, but in this particular case, it won't fit because of the tool rest. And I just need to level this surface. So I've got a flat plane, and I can see it's out by a lot more than I thought. So it'll take a few cuts to get there. This is a peel cut using the wing of this gouge. This gouge is very effective at peeling, but it is not a side grain finishing tool. It is an end grain finishing tool. It's 40-40 grind. I'm just using this particular grind to speed. So I'm just getting this level. And what I want to do, I want to get it on a chuck. If I get it on a chuck, I'm keeping myself safe and then anything around me. So we're just doing a peel cut. It will not be a good finish. So let's put it on I think we just stick it on this big guy here. I think we just do 4-inch jaws. It'll be easy. So let's chuck here. So I'm going to scoop in here, cutting in, and then cutting from the other direction. It gives me enough room to put, I'm going to put a tenon on this and just grip on a tenon. So to cut that tenon, actually we can just do the tenon with the gouge. So let's just make a bit more space because it's going to be a volcano bore. So I can actually cut this with the gouge, cutting in this way, and give myself a shoulder. And then I'm just going to make sure I've got enough clearance around there that I get location. So just make sure that shoulder's good. And we're good. We can put it on that. So now when I put it on the chuck, I'm locking a piece of wood in there. And just make sure it's not too long. Recently, Vicmark changed their design of the jaws on the outside. This taper used to go all the way down to the back so you could put it in at any depth, but they then put a step in here and it kind of like spoiled the best chuck in the world by putting a step in there. It would have been so much nicer if that taper just kept going because then I can put it in any depth. But in this case, I'm actually gripping on the inside. So I'm grabbing a tenon. And this is a big enough tenon that it's not likely to snap off. This is a big tenon. Okay. All right, so what that's going to let me do is get a proper grip on this and lock part of it into the chuck. Okay. So that's just a little faceplate with some cheap fasteners in there, and it's got a really good grip. It's a little bit, this drive center is an oversized 1.5 inch. It's pretty good, but that's still much more stable. And I'm going to put that over there because I'm very good at leaving drive and live centers in other people's lathes, and I never get them back. So now something important. We put the chuck down on chips all the time. So there's chips on there. So when I put this on here, I won't notice it's running out of true. But when I flip the bowl, I'll then notice I'm running out of true. So really important to wipe the back off, make sure that's clean. We need our chuck to be running true. Remember, number 2 on that list is the chuck. So it needs to be location or accurate location so that we know that we're going to run because we are going to flip this piece a couple of times. So if we keep flipping it and it keeps moving off center, you get what's called a stack tolerance. And all of a sudden, the wings of the bowl won't be even on both sides. And we need to keep it pretty even. Now, this is wet wood. Now, if I was doing one of these to sell, I would likely turn it out of wet, leave it thick, come back and finish it later. But it's a demo. And also in demos, if we can avoid using dry wood, it's advantageous just because we're all in a room where we're not wearing masks. We don't have dust extraction on. By the way, I noticed it. I think you guys mentioned you're going to do a meeting next month specifically on mentoring for demonstrators. I might be interested in coming and doing that. I've done a lot of demonstrations, more than anybody else in history. So there's a few tips I can give, especially if you want to be able to get to demonstrate for like SWAT or AAW or the regional symposiums. There's a couple of tips on that because after a while you get when you've done a lot, you're going to be nervous the first time you turn. A couple of little tips is if you are demonstrating, you've got to be able to talk while you're working. But then that sometimes takes away your concentration on what you're actually doing. So you have to practice. Here's just something about if I come to this demo tonight and says, hey folks, I'm going to make something I've never made before, then you should leave the room. Because then I'm not a damn expert, am I? So I've been many a time, I've walked into a demo and the person's gone, I'm going to do something I've never done before. And I'm like, I've seen that go so badly wrong. So talking about going badly wrong, I am 21 years old. It's the 3rd British wood turning symposium ever. And this guy called Mike Smith was his name. He was pretty famous in the UK for doing like really like extravagant work with chainsaws and burning and crazy shapes. And I thought, I'm going to go and see him. So I walk in the demo a bit early so I can pick my seat. And I'm looking at the setup in the lathe. I'm thinking, oh my, that is very dangerous. I'm thinking, nah, he's not going to turn like this. He's going to do something when he comes in. So anyway, I sit at the back and off to the side. And I'm pretty young at the time. I'm just early 20s, I think. Maybe he's 21. And I'm sitting beside this older guy, and I nudge him. And I says, "I think he's going to get knocked out." And the guy says, "Are you kidding me?" He says, "That's Mike Smith. He knows what he's doing. He's an expert." I says, "I don't think so. I think if he switches that lathe on, he's getting knocked out." The guy says, "It's time for you to shut up, kid." And I'm like, oh, British mentality, never trust a kid's judgment, you know. Anyway, so I said, well, okay, let's see how it goes. Mike Smith comes in, he says straight away, I've never done this before. And I'm like, oh, it's definitely going to go wrong. He's turning grass tree root. I don't know if you know what grass tree root is. It's actually grass. It has no grain structure. He's on lag bolts on a faceplate, and it's 3 foot long, and there's no tailstock. And he's going to turn it slow, though, and he's going to chainsaw whilst it's going slow. I'm thinking, what? You've never done this before, and he's going to do it. So, classic. Switches on the lathe. It comes straight off, knocks him clean out. Then I said, this guy, see, I told you so. And we dial 999 in the UK. You guys dial 911. I said, I'm dialing 999. Then the guy came up to me later, says, "So who are you?" And I says, "I'm that Stuart Batty you see on the front of the woodturning magazines. I do this for a living." So anyway, he didn't see us. You couldn't see that that was going to come off. So we don't want it to come off. This is not a round piece of grass tree root, right? They didn't weigh very much. This is a 10-pound block of wood that I need to take the speed up to cut clean. So I am on a 4-inch tenon and I've got my tailstock. And I know we mentioned somebody's name before from Vegas. He would turn this with a smaller tenon, full speed, and no tailstock. That's up to him. Don't do it. It isn't worth it. It's just a freaking piece of wood. You don't want to get hit by it, and it isn't worth the risk. So I can take my speed up a little faster now, but not yet. I got too much imbalance. So I need to get some mass down. So by the way, we are making really advanced wood turning tools. This is the most advanced gouge ever in the history of wood turning. It is a laminated 15V, the longest edge steel in the world. It is beam shaped, so it's taller than it is round. It has the longest cutting edge in the world, but it's a bit big for this lathe. So I'll pass one around that you see. It's replaceable tip, and it holds an edge. So you guys have heard of M42? It holds an edge 5 times longer, and it'll cut right through the bark and not dull. So let me pass one around. I'll pass this one around. I'll use a smaller one. Anyway, we have them for sale in February or March, maybe, because we've sold the first batch, so we don't have any spare ones. But it's just a new technology. This is a gouge that I wanted Sobeys to make 40 years ago. But remember, I wasn't an engineer, so they said they just ignored anything I said. I said, we need better steel. We need it to be a different shape. We need it to be stronger. Look at that thing. Gets weaker as it goes back. Gets weaker. Since when should something get weaker as it goes back? It gets stronger as it goes back. So let's use it a little bit for this so it'll be fun. But this thing is so fast at cutting, being only 2 horsepower, I can actually stall it. So, but we can have some fun with it. Okay, so it'll cut right through here. So here I'm going to cut sideways. I need to get mass out of this so I can peel in, because I want to get the speed up. So I can take really big bites if the lathe can cope with it. So I'm leaning in. This is a peel, cut with a wing, slice with a nose. And see how much, so that's a bigger cut you can take. It's an okay horsepower, yeah. Notice I got a bad start. So that I got a little bit of a bounce at the start. Because I was starting on an uneven surface and I pulled onto that uneven surface, I took that bounce with me. So notice I stopped and I re-go again. I'll go with slightly less volume. I need a good start or the cut will always be bad. So if you start off and you get a little bit of vibration in the tool, it will just continue in harmonicking. You have to have a clean start. So as I went in there, I wasn't getting a clean start, and therefore the harmonic just continued in the cut. So here, get a clean start. There it is. Now I can accelerate up. And now what I'm going to do here, I've moved removed an inch of material. I'm going to move my tool rest to a better, more optimum position to do the same technique again. But look at this gouge. It's really clean at cutting the end grain, but it mulches the side grain. That's what the 4040 does. It's a side grain removing machine. That's what it does. But it only finishes end grain. It doesn't finish side grain very well. So we won't use it for the finish on the side grain, but it'll get us there quick. So now that we've gone with that, let's give ourselves, make sure we're still tight on everything. Let's get our speed up if we can. Another 150 RPM, so I'm at 1,000. Now here's the thing, there's bark on this. I do not know if the bark will stay on this oak. So sometimes it will, sometimes it won't. So here I want to be a bit more gentle with the cut because I don't want to burst out the bark. And I'm making just making a gradual curvature here. We got, at least a third of the mass off. So now I want to look at thinking about the shape. So I'm doing a volcano bowl. So what is volcano bowl? It looks like a volcano, like a mountain that's blown its top. So right now, the tailstock is keeping me safe, but it's blocking the path of my tool. So what I want to do here is I'm going to cut in a little bit from this direction because that's going to give me a better finish on the surface because I'm punching this corner out and then I'm going to blend it the other way and then I'm going to use negative rake scraping. So negative rake scraping is a technique I developed about 40 years ago to help me make this kind of bowl. The problem with this kind of bowl is the gouge likes to cut outwards because it's laying the fibers against one another, but then it's punching out the corner. If I cut the other way, I'm cutting the grain the wrong way. And also it's an intermittent cut. So the gouge needs bevel contact to stay really clean. But I like to keep my tailstock there and my tailstock's in the way. So right now I am using the wing of the gouge in just a peel cut with very little bevel support. So I'm not getting a good finish here. I'm getting a great finish here where I use the bevel. But you'll see as I travel around that corner, a little bit too close on the bark. As I travel around that corner, I'm going to hit the tailstock. I've got the option. Do I remove the tailstock? It's a risk. So let's see how far we can go. So as I go around here, how far can I go? No, I'm there. I'm at my max. I'm already hitting the tailstock. Can't go. So here I'm using a peel cut, which is not a good finish cut. It'll help me get rid of both, but this will not give me a good finish. Peel cutting does not give you a good finish when there's any end grain. If I cut this way, I'm breaking into the fibers. Now I'll get a cleaner cut, but I'm tearing the grain. So I'm going the wrong way. Not that I can't cut it and control it, but I'm tearing the fibers out here, the bark especially, and I'm going against it. But I can join the two cuts up, and then I'm going to use negative rake. And like I said, I developed negative rake in my early 20s to let me make square bowls easier than doing it with a gouge. For years, I'd used gouges, but the gouge level of skill, especially when I started teaching, was like, oh man, to cut through air and get a clean cut on this bigger surface is tricky. Now, can we afford to speed up a bit? We've got half the weight off. Yes. So now I'm at 1250, not 3,500. So let's see if we can get a clean cut. Now, this is a pummel cut, so I don't need tool rest support for it, but I'm going to get a bit more of the bulk off. So that I'm not using my negative rake any more than I have to. And I'm cutting the wrong way. Let's see if that shape will work. So that's the kind of shape I'm looking for there. And what we'll do, we're going to undercut the bottom and we're going to use what's called a vortex tool. I developed that to make this little really hidden bowl inside later. But this is pretty close to where I want to be. Do I want to be a little bit thinner? Yeah, I think we afford one more cut. So again, let's cut in the wrong direction. I can't cut this way with my bevel in contact because my tailstock's in the way and I do not want to remove my tailstock for this. I'm going to give it an extra 100 RPM and just glide that through. Now this is 15V, so I'm not going to resharpen it. If I was using a regular M2, M4, M42, I would have resharpened the gouge for sure. 15V, hold this out 4 times longer. Going to position myself in a little better position here. And let's just get the rest of the negative rake there because I can't get round any further. So I'm kind of in no man's land. So all I've got for negative rake is just this little guy here. I'll sweat that guy. So negative rake is a double angle chisel. I know you guys think this is big. This is not big. We have one that's 6 1/4 inches wide, but I just didn't bring it because I knew Jessica was gonna have to carry it in. It's heavy. I just grabbed this one because it was what was available. And we don't need such a long handle. By the way, so in Boulder, we make these blades, these tools. We make the platform systems you see here. We make carbon fiber modular handles. We make very advanced tools. We made them how I wanted my tools to be. So we don't compromise. We don't make anything that I wouldn't personally use. So negative rake scraping, it's been around since ivory turning, and ivory turning used to be very common in the 1500s. The British and the French and the Germans used to turn ivory and make a very ornate. Now, obviously, we don't turn ivory anymore. And when they turned ivory, they would use a scraper that had a double angle, but no burr. Now, on wood, if you use a double angle, that would be a skew chisel on its side. Did I bring a skew chisel? I brought one somewhere. Oh, one's missing. Ooh, maybe I didn't bring it. Okay, where is it? I've got a small, here's a small skew chisel. Here we go. Thought I brought one more. I think I left it behind. Okay, anyway, this guy. This is a skew chisel. Guys all familiar with it. It's probably just a 3/4 inch one. So with a skew chisel, if you use it as negative rake scraper and you've honed it, it won't work. If you use a negative rake scraper with when it's already dull, it won't work. It relies 100% on grinding it and putting a burr on the top surface. That burr abrades the surface, and it isn't actually scraping. It is abrasion. When the burr is gone, it becomes a scraper, and it becomes a lousy scraper. But if you use the burr, that burr is the same as the grit on here. It's abrasive surface that abrades away. Unfortunately, it's just one layer on the edge, whereas this is millions of layers. That's why the CBN lasts for years, and this lasts for 30 seconds. But in 30 seconds, it's magical. It can remove a lot of material in 30 seconds, and as long as the burr doesn't wear down off completely, then it won't tear the grain. But if the burr disappears and you keep going, you will tear the grain. So it's a form of abrasion, but unlike sandpaper that might get a couple of minutes, you don't have a couple of minutes with this. And this is exotic steel. This is 10V, which is the second longest steel in the world edge. But even this, with this length edge, probably it might give me about a minute and a half of working time. But that's a lot in a minute and a half. I can take off, it's going to work like 16 grit that fast, but with a 320 finish. That's the difference because it doesn't flex. So let's see, lock, true rest, not changing anything. And okay, this is negative rake. So this is it here. It's very effective at cleaning this surface up. I don't want to be super aggressive with it because obviously it's a finesse tool. I'm not supposed to be reshaping. I'm using it a little bit more aggressively here than I normally would for the simple reason that I couldn't get in that corner with my gouge. But here it's just exceptional. The finish here, I can start sanding with 220 grit. I can go in both directions. I can have the whole surface area touch and it will not grab. This is negative rake. As long as the tool is correctly used and supported, it doesn't grab like a regular scraper. I'm going directly into end grain there, and I am not getting a catch. If I used a conventional scraper going into the end grain that width, you guys would be looking at this handle very closely. It would just pull it out of my hand directly into the end grain, and it would smash through this. That's conventional scraping. But by putting a negative rake on it, it is inert. It doesn't push the wood away. It doesn't pull the wood in. It's inert. The only downside with negative rake is it's a very short life. So, sure. Yeah, I can't see. Oh, there is camera. Oh, good. All right, there we go. All right, there you go. Which way? Where's the camera? That way. Oh, there you go. That is. It's just, and you just offset the blade there a little bit. This one's pretty worn down. I had to borrow this off one of my employees because we sold out of them. So we got more in production, but we sold out of this little guy because pretty popular inside a bowl. And so he can see he's worn it down a lot. He's probably used it on 20 or 30 bowls because he's worn it down a lot. But it's still got another 20 or 30 bowls before it will wear out. So it's still cheaper than sandpaper because look what I got. I haven't sharpened that, and I could sand that right now with 220 grit. No problems. In fact, I'm not going to even sharpen it. I'm going to leave it right off that. Let me see if I got the shape I want. I think it's pretty good. Feels good. I'm going to go one more time. And so sometimes I'll search around for a fresh burr on this because, it's a very long edge. So maybe a fresh burr. There's a fresh burr. I haven't used all the edge.
It's very user-friendly. Now, you could make one yourself. So you just buy a skew chisel and you round the front. It works the same. The advantage we got here is it's just a bigger working surface area. This is sharpened at an included angle of 40. You can go up to about 70, but after 70, the burr is so small, it's ineffective and it doesn't last long enough.
But that allows me to cut a surface that would be really tricky to cut with a gouge. That would be a long cut, which the cut would start great until I got out here. And then the gouge is going to want to punch the corners out because it's cutting towards the corner. Whereas here I'm working it and that's it. It's done. So I think we can flip that around. No, I can go flat to 20 degrees down to flat to 20 degrees, not 20 degrees. That would be pushing it. 15. If you go to 20, you're turning it into well, how do you know? You'd have to go. Yeah, you could go to 20. It wouldn't catch at 20. You've got a big range. Conventional scrapers have to trail. And I love it when I've seen like a demo where people say, oh, negative scrapers are BS. Just take a regular scraper and point it downhill. Yeah, you always point a the regular scraper downhill because if you don't, it grabs instantly. Negative rig doesn't need to point downhill, but it has a limited life. So regular scrapers don't really have a limited life. It just, the longer you go, the more it tears the grain. Regular scrapers don't generally give you a good finish. When was the last time you used a scraper and went, oh man, I could sand that with 220 grain. Now you go now I start at 60 to get rid of that torn grain. So it didn't tear the grain. Now, will this work on spalted wood? No. Will it work on really soft wood? No. But will it work on ash, oak, hard maple, honey locust, anything dense, anything exotic, more exotic, blackwood, cocobolo, the denser, ebony, the denser it gets, the better and better it works. Remember, this technique was originally developed by the English to be used for ivory, but it was never developed in wood turning until I had to solve this problem of making lots of square bowls. And I need a better finish because I can't quite get the finish I want with the gouge without a lot of hand sanding. Right now, I can sand this in probably with 220 grit for 30 seconds, and it's ready for 320, 400, done. 3 minutes of sanding. I got a surface that's finished. I'll pass this around. When you pass it to your neighbor, it's pretty sharp, so you don't carry this on the plane, as you can imagine, because believe it or not, I had one of those in my bag, and I went through check-in. I didn't know it was in my bag. I'd been to the machine shop that was doing some work for us from some prototypes, and the prototype was still in my bag. But I didn't notice it in my bag because I had a laptop and an iPad, so it felt normal weight. And they kept putting it back and forth, and it slipped in this back pocket, so it's kind of hidden. And they said there's something dangerous in that bag, and I'm like, I don't have anything but a laptop thing. And then he pulls it out, and I'm like, oh. I says, do I lose it or do I go to jail? So I'm thinking this has to look like I'm going to be a slasher on a plane. Anyway, they just says you lose it. And yeah, it said you mail it to yourself, and you already held me here for 30 minutes. I'm not even going to make my plane if I try to ship it back. Anyway, so the included angle is very steep. Why is it so steep? Why is it 40? Why is it not 50, 60, 70? The sharper the angle, the bigger the burr for the least amount of effort. That's what it is. If you do it at 90, there is no burr. If you do it at 80, the burr is tiny. 70, the burr grows. 60 keeps growing. So, but less effort. I'm just by grinding the same as my skew chisel. This is set for a skew 20 and 20. I grinded at 20. And we use 10V there, and we do have 15V. We've only got 15V in a few of those. 15V would give me an extra 50% exactly longer life. So you saw that how long I worked that for was maybe a minute and a half. I would get 2.5 to maybe 3 minutes of cutting. That's a lot of effective cutting time on that surface. All right, let's hollow this out a little bit and reverse it. Okay. Yeah. No, it's different. That's a great question. Really good question. I like these types of questions because I forgot all about it. Raising a burr isn't a burr. What is it? What is a raised burr? Because it isn't a burr. What's that? It's a curled edge. So it interacts very differently. And here's the downside. Yes, could you curl the edge on it and make it work? Yes. Will it work just as well? Not bad. Here's the problem. When it does, I have to do way more work to fix it, to get it back, to put the curl down in. Whereas here, I just rub it around the grinder. Can I borrow it back for a second? I'll show you how quickly it is to sharpen. Okay, thank you. I'll just sharpen, I'll pass it back around. Okay, so this is the sharpener, and this has got a pretty long edge. I don't know whether the camera can turn or not. Can that turn? No? Anyway, hopefully you can see. Oh, is it set at 20? All I'm going to do, I can't do it left. Well, maybe I can do it left-handed. I'll do it like this. That's all it takes. I'll go back one more time just to make sure I got it. So I'm doing a kind of awkward angle. There we go. Sharp. That's it. It's fast. Yeah, because one side, you'll see Tom Worsing when he does the platters, he sharpens both sides, but he never wants the shape of his negative rake scraper to change ever. He wants it exactly as it is. So he sharpens one and then cancels it out from the other. So he keeps the exact same shape, same radius for his platters. And Tom Worsing developed making the best platters in the world. I mean, Tom Worsing, your local turner, he makes the best platters in the world by far. I've seen everybody else's platters. They're flawless because he uses negative rake. There's no way of clean cutting curly figured maple where you don't need a little bit of aggressive sanding, even with my techniques of cutting, because the grain is crazy. But negative rake scraping means he can start sanding at 220 with a minimum amount of sanding. So his finish on that figured maple is flawless. I mean, when I say flawless, as good as any human ever has in history because he used negative rake. But you have to be careful with negative rake. Why? Makes you lazy because it fixes a lot of crap. But don't use it. I used it more there today than I normally would ever do. I'd never normally take that lump out. But I didn't want, probably at home, I'd have removed the tailstock. And gone, nah, what does it matter? You know, I'm not standing in front of it. But I didn't want to take the risk. And now I would have cut a little bit further with the gouge, but I couldn't with the tailstock there. And I would have taken that out. But you saw it took that out. So it did quite a bit of work. And then it still had a burr enough to finish it. But if the burr is gone, negative scraping is lousy. It's awful. It just doesn't work. It has to have a burr. So don't keep working it till the burr is completely gone and then look at it and go, oh, it's not so good. You must put the burr back on and then finish one more time. Don't let it go completely because then you damage the surface. I didn't resharpen that. And this surface, I would give this a 95. Could I get the surface a bit better? Yes, if I used it fresh now that I've sharpened it. But we're going to move on. Okay. No, you wouldn't actually notice it. If you look at it under a microscope, it's just a bunch of garbage steel. That's all it is. So dropping it down just makes it harder to get the nice flow. I'm just keeping it flat. Flat because it's easy. That's it. By the way, anybody here do shear scraping? Anybody use shear scraping as technique? Shear scraping is negative rake scraping. You're just holding the burr at a different angle to the bottom of the chisel. And therefore, shear scraping is negative rake scraping. The reason I've never shear scraped my whole life is because I've got negative rake. Shear scraping requires me to keep the tool at a certain angle. I'm on the corner of the edge. I'm pulling it round. It's tricky. Negative rake is not. It's shear scraping on steroids with much greater ease, much more blade surface contact. I can use all of the blade. I'm not balancing it. It's just flat and go. It's very effective. But remember, it doesn't work on certain woods that are soft. It doesn't work on spalted wood ever unless you impregnate it with acrylic or cactus juice, then it works fantastic. On plastics and acrylics, it's unbelievably good and it won't ever grab. As long as you use it correctly. When I say correctly, don't have your negative rake pointing up at a silly angle. Make sure it is flat and it's supported. Then it's good. I better quickly move on a little bit here, folks, because I need to get some guts out of this thing. Oh, you can see the yolk starting to have effect already. See it? It's starting to make the bed of the lathe a little bit sticky. Okay, and this is a swing away, which I'm not going to use. Will it swing it away enough? Okay, I gotta think how this works. I don't use the swing aways for my Powermatics. I use a long bed. So about the same price to get a long bed. I recommend the long bed because it only adds an extra foot, but then I don't have to deal with doing this every time. And then I got to pull it back. And then if you leave any chips like there, see those chips on the top? That'll stop it going back. You have to get those out when you put it back, or they'll stop it locating. Okay, let's hollow it out a little bit. I'm just going to use a small gouge for this. This is just a one-way gouge. Our handle system lets you put anybody's blade. This is a one-way gouge. I've got a Carter. I've got every kind of make in there. And our system is just a taper lock. So that allows us to just put it in, take it out. So I can change blades or sharpen real quick. Now, remember I've been turning a little while. This wood will definitely compress a tiny bit. I should have done that whilst the tailstock was there. But now that I'm hollowing out and I'm not standing in front of it, I can remove the tailstock. I want to get it ready to put a chuck inside there. Then I'm going to flip it over and finish the back of the bowl. So let's start it off. And we don't need that much speed. And let's trim up the face. Okay, and let's take advantage of one thing. I'm forgetting, sorry. Why am I reaching past the corners? So I've taught a lot of classes where maybe it's on day 5 we do square bowls like this, not necessarily a volcano, but just a bowl with a, in the middle and wings. And this is such a huge advantage because the amount of times, not that many times, maybe it's 3 times, people have gone for the off switch, the shortest route through the corners. Now they're not going to seriously hurt, but it still wraps your fingers, and you go like, why was that so stupid? So if you do a lot of these, and you want to make them, is you got to learn to go around the tool rest always. But it doesn't take a moment of lapse where you go like, and you reach through. So putting over here, I don't have that. I'm taking away that risk. Let's just level the face here because that's definitely out of true. Now I don't want to take too much out right now because I've still got a lot of mass here. So I'm forming what's called a V cut. Yep. I notice as soon as I've got stability in the cut, I move my hand away from the tool rest because it's in the way. So we'll get some of the guts out. In fact, let's get a little bit of the guts out right now. From a V. The V cut is giving me depth, and then I can make some space. Worry about hollowing that out again later. So which chuck am I making it fit for? Let's see, probably, I'm so bummed that these ones are better. So this one, they see they've got a step on this one. Where's the camera? Okay, so you see how they put this little step down here. And if they'd just taken it all the way down the corner, I'd have a much deeper, longer jaw. And I'd much prefer that. I have no idea why they put the step there. There's plenty of steel there. It's not like it would have weakened it. Whereas on this one, their original jaws, they haven't done that. This goes full depth. So I'm going to use this one instead because I get full depth. I don't have to worry about bottoming them out on that little ridge that would create me problems. And this gouge, again, will create a 40-40 here. Sorry, the 40-40 let me make a recess and a shoulder and an undercut there. So I want to go in a nice step out there. And we can locate on that. Ooh, remember, I moved it. Okay, so now we're going to swap it round, put on the chuck, and then we're going to bring up the tailstock again because we're on the safe side. So anyway, talking about Princess Diana, I never met her husband, but I do have a story about, King Charles now. You guys aren't live streaming this in England, are you, by any chance? Oh, man, I can't tell you the joke then. Hey, I mean, are you sure? Oh, great. Okay, okay. You're not going to send it to King Charles? Because, oh, did it? He's on Zoom day. Okay, good. Good to know. Because, hey, Princess Diana was the most famous person in the world, correct, at the time. Everybody, if you lived in Africa, Vietnam, you knew Princess Diana, right? Famous, beautiful person. And all of a sudden, she dies. I mean, my government can make anybody disappear. And it was a car crash. Of course, it was a car crash in a tunnel. Most famous person in the world with a private driver, security guard, and her and her boyfriend, who happened to be a Muslim, which in the UK at the time, the dad who owned Harrods couldn't even get citizenship in England. Not that England's racist, but they saw all of a sudden Princess Diana's hanging out with a Muslim. She's supposed to be the next queen. Bingo, she dies. So you think if I'm going to tell you this joke that if they saw this live that I wouldn't die in a tunnel? You guys got the Eisenhower Tunnel, man. That's a long tunnel. I go through there all the time. Like I'm saying, the Brits are really good. You know when the Russians snuff somebody because they use polonium or something pretty obvious. In England, we've been doing this for centuries. When you want to be gone when the Queen says off with their heads, I mean, she meant it. So anyway, back to the story. So Princess Diana's out of the picture, and Prince Charles is a single man. So he buys himself a brand new Rolls Royce, and he invites Camilla Parker Bowles, to come drive around Buckingham Palace. He's going to give her a tour in a new Rolls Royce. So, he's sliding it around, driving it fast, when all of a sudden he runs over one of the Queen's corgi dogs, flattens it like a pancake. He knows Rolls Royce are friggin' heavy. So he gets out and he's in a panic mode. He's thinking, Mom is going to be so upset with me. So he's thinking, but look, lo and behold, up pops a little leprechaun, says, Prince Charles, it's your lucky day. We can grant you one wish. He says, thank goodness. He says, come look at this corgi. Sorry about that. The leprechaun comes over and he looks at the corgi and he says, oh, that's way too far gone for me to be able to revive. the corgi. But he says, since I haven't given you your wish, you still have it. So what's your second choice? And he looks at Camilla. He looks at the leprechaun. He says, can you make Camilla as pretty as Princess Diana? And the leprechaun says, let me take another look at that dog. That would definitely be my head off. Hey, we've had kings that have killed people for a lot less than my joke there. So okay, so we're on a chuck. Let's just check it's running true. Now, remember, I made sure I cleaned the back of the chuck. I made sure that where the locating face was true, because if this chuck is running out of true, then the bowl will run out of true. So let's not start crazy fast. Yeah, let's start super slow and let's just check to see if it's running pretty true. That's pretty good. Let's make sure that the tailstock is going to locate correctly, which it does. It goes back in the original mark, so we're good. So then we can give that a little pinch. Now we're good to tighten it up all the way. Now, remember, I'm expanding inside. Now I've got about 3/8, maybe a little more of wall. I can't go crazy because I'm expanding. I could burst it. So just pinching it, pinching it. That feels about the max I can go without threatening to crack it. We don't want to crack it. Okay, so let's put the tailstock back, sorry, the tool rest back here, and let's start working our thickness. Now, here's where I can use a gouge successfully to clean off most of this because it's going to be faster, but I'm still going to finish with negative rake. But on a negative rake now, I'm going to have to use an opposite shape. Instead of it being convexed, it's just going to be straight across. Okay, so we're set. We can get rid of some mass. Yeah, probably more like 3/16 to a quarter away from it. I don't want to be too close because it's not going to let me engage the tool before I hit the wood. So I don't want to be super, super close, but I've got enough clearance. And here's something about this one's not off center. When I'm doing an off center one, I'm checking it a lot more because on an off center one, it's really easy to forget where the last corner is. But this one, all the corners are pretty even. So if one corner clears, all four corners will clear. But when I do off-center ones, you have to check it all the way around every time because often you'll clear 2, 3, but not the fourth. Let's get rid of some bulk. And just thinking on time. So I've got another half an hour. So I'm going to have to crank on a little bit here. So let's start slow. We can take the speed up again. Now it's going to face the shield because I'm going to be looking through the piece. Thank you. Let's come in here. Now, again, my hand is on top. Normally, I don't like my hand on top, but I'm going to get rid of some of the bulk here. Yeah, starting on a bouncy surface because it's not flat. I've got to get a good, clean cut going in here. Now, what's the volume here? Because I am cutting a little bit towards end grain. As I come around the corner, it gets to be a little bit more side grain, but there is a high percentage of end grain here. And then I'm going to remove some of the base. This is where this tool rest and this little handle thing gets a little bit in the way here on this lathe. Be careful I don't take off too much there. We'll shorten that a little bit because it wants to be lower, or sorry, higher than the bottom of the bowl. And let's go for one more cut around here, then we'll move over to the negative rake. Now, one of the things I normally do, but I don't have the opportunity, I would normally put a light on this side. It lightens up this side to know where I am. And then it lightens through the corners to where this gouge is, and I can see it more clearly. But the wood and the lathe color are about the same. So it's kind of hard to see it, I must admit. It'll be easier with the negative rake, but it's kind of tricky with the gouge. I'm not getting a high percentage of end grain, so I'm going to reduce the volume. You notice there I blipped the cut. I was cutting, then I backed off. I could feel I was getting too much harmonics because I was cutting too fast. So getting close to where I want to be. But here's what's happening now. If I can bend it with my thumb, then the gouge is going to deflect it. This is when negative rake can still keep cutting and the gouge can't. But let's get a little bit closer. We've reduced probably 70% of the mass, maybe. So I'm going to go a little bit further with the gouge. Then I'm going to get rid of the tailstock because it's too much in my way a little bit, especially even with a negative rake. So let's get a little bit more mass off here. A little bit more here. And then what we'll do is we'll retighten the chuck and we're going to work it without the tailstock here. Because now it only weighs, I don't know, it weighed about 9 pounds. Now it probably weighs about 2. So pushing the gouge? No, it's just a weight. So I never push with my left hand ever. Never, never. It's just simply a dampening, positioning tool. So I use my left to position the tool, and all my left hand is always doing with any gouge is always just a dead weight on top because the gouge is light at the front. Because gouges point uphill, even though this has got a bolster that weighs about 1 pound, the handle doesn't weigh much, and the blade probably weighs 1 pound. They're still very light at the front because the weight is downwards, because that's why gouges work. So I'm putting a compressive force on the tool rest just to make the tool act more like it's 3 or 4 pounds at the front to stabilize it. So, but I'm not controlling. So my style of turning is single hand control at the rear. So I am driving this gouge by to cut. A curved cut in wood turning requires push. Oops, not that much push. It requires push because you need to travel. Remember, the wood is the wood moving on the lathe? It isn't moving. It's statically rotating. So it's in a static position, but it's rotating. So for us to form shape, unlike on a table saw or a router that we're moving, well, like a router, we're moving the tool to form the shape. And the spinning is allowing us to do the cut, but it isn't actually moving other than rotating. So we have to push to create the shape, create the distance. We have to lift and drop to get the right control of the tool, because we're trying to pitch it in, and then we're twisting the flute to get the optimum cut, and then we're swinging to make curvature. If you stop swinging, you go straight. So right now I'm swinging to make curvature, and so so push, twist, lift, and rotate create my curved cut. But none of those are done at the front of the tool, because if I'm doing any of the front of the tool, I'm either pushing on the bevel or pulling on the bevel, and then I've lost control of the tool. I'm using the bevel most of the time, not 100% of the time. Like here, I'm going to get rid of this little noggin. Here, now, do not cut into that noggin, because then I'm going to snap it off. I'm going to cut this direction into the side grain. I don't want to cut into the end grain. So you've got a choice of which direction to cut. Hence, grain is the most important thing on the list. So cut the correct way. So I can cut into this going into side grain. This way is easy. That's side grain, no problems there. Let's put it a little bit, we want to be a little bit lower still. Very careful, don't make it too low, because when I hollow it out, it's still going to have something to grip on. Speed is, we can go up to 1250. Let's get a cut around here to form some of the shape on the bottom of the bowl. I've left a little excess on the bowl here. We're putting a candid on the bit, and we'll take that off later. But what we need to do now is we need to finish this area to get this thin. So I want this down to 1/8 of an inch. And could I keep cutting it with the gouge? Do one more cut with the gouge. Okay. By the way, sharpening. Don't want to spend too long on it. On my website, there's a half-hour video how to sharpen every tool. So basically, I'll bore you sensitive if I do it now. Plus, I don't have much time to go over it. So I've set this at 40 degrees with an angle gauge. I've set 2 lines at 40 on one side, 40 on the other. That gives me, when I swing between the 2 corners, not falling off, I can do to the middle, to the middle. There's a little bit more going on here than I'm revealing, but I cover that more in the video on grinding and sharpening. You can't learn to grind and sharpen from watching me do it on that. But I think I can get one more cut here to get this a bit thinner before I move to the negative rake. Reduce my negative rake. It hasn't warped, so we're good. We're going to go up to just over 1300 to get a smoother cut, but I want to get to the negative rake as soon as I can. But you can hear the wood wanting to flex on the gouge, because gouges push. Negative rake scrape is a neutral.
And I didn't bring, I thought
I brought I don't think I brought it. I think I forgot it. I'm pretty sure I brought a bigger, oh, there it is. Aha, I did bring one. Okay. Bigger one. So this is a skew chisel that is just wider. It's going to give me more cutting time. Okay, now I've got a burr's on the wrong side. So yeah, it's on the wrong side. So I'm just going to grind it on this one. I know it's not on the camera. Just going to put the burr on this side. And that's all it takes. This is 10V. So it's not as long lasting as 15V, but it'll give me probably 45 seconds of cutting time or working time. It's not cutting, abrasion time to get that down to a better thickness. Here, good. Check it.
let's go for it.
Sorry, what was that question? Half an hour. Oh, okay, we're good. We'll get it done.
I do want to get it finished. I mean, it's not going to be a finished piece, but you know what I mean. We'll get it at least jam checked and what have you. So this is where negative rake is incredible. This piece of wood, I can take it down to a 16th, no problems. It won't care. Negative rake does not push on the wood unless I push in hard if the burr's gone. Now, unfortunately, I can't see the thickness as well as I would like for the simple reason that the lighting is wrong.
Normally, like I said, I put a light on this side, and what that would do, that would highlight where I'm working to. Right now, I don't know where I'm working to because everything's looking
the same color, the lathe, the wood. Yeah. So this burr is starting to go. I can feel it already. I've been working for quite a while, but it's going. Remembering also, I'm working bark there, and bark is exceptionally good at killing edges. So let's put a quick fresh burr on it and go again. So putting a burr on like this costs maybe 10 cents. So it's still a lot cheaper than sandpaper. You see how much more effective it is with the fresh burr? Really effective. And I'm able to work all the way in, all the way out. This is taking off quite a bit of material. This is taking off more than any sandpaper would, but giving me the finish of a 220 sandpaper. And let's have a look. If that bit's finished,
then the rest is easy because this is the most important part of the bowl is here because this is where I don't want to break the corner out. Ooh, and Ellie pushed the bark off, punching it there. The bark's staying on though, for now. But the bark is flexing a little bit more than the wood. So the bark isn't thinning down. The wood is, but the bark is, it's flexing so much, I can't thin it. See it? Wobbling. Oh, well, it is what it is. It's just bark. We'll pit. No, how much I'm pushing, and it'll change the tone. All of a sudden, it'll make a screech noise if the burr's completely gone, because it'll screech. It'll make like, because it'll be stressing the wood too much. I've got a little bit of the burr left, but not a lot. In fact, let's not chance it. One more burr, why not? And then I always check that I got a burr. Yeah, I got one. In the tourist, and then, like I said, the bark's not, it's barely wet. The bark's very soft. It doesn't like the bark. And that's where we're going to stop. Let's just move in now and get it up down here. But you hear that little screech, that's me pushing hard. Just I'm speeding things up. And that might do it. So that gets me the wing, but it's very easy. It just for anybody here, you would have no problems in doing this technique. I'm just being careful and guiding that I don't get thicker or thinner as I go in. I'm getting very slightly thicker, so we'll go one more time and then we'll move on. So clean the tool so it doesn't stick, because this was a bit gummy. And the blade is starting to get dull. It's still cutting, but it's starting to fail. I can feel it. We'll stop with that. Let's do the bottom of the bowl. Actually, we're going to round it in a bit more. with the 4040. Then we're going to go to a vortex tool. I developed both negative rake scraping and a vortex tool for doing this type of bowl.
Which I'll show you what the vortex tool is in a minute. You'll have seen Cindy Drosder, Ashley Harwood use it for finials, but it wasn't actually designed originally for those. I designed it to allow me to get into the deepest cut at the lowest angle ever in wood turning history, which is 20 degrees. I'm going to get into this corner with 20.
This gouge with a 40 and 40, its included angle is 80. But I get in there with 20 because I want to get this to go really high up into the bowl. So I've got this particular tool. Originally, I just used to make them out of a, how much you can use a shorter handle. I used to make these originally out of a spindle gouge, where I grind half the spindle gouge down and grind it into a point. This is a really bad grind is what it is, but it works great. It's ground on 20 and 20, and I grind it. It's got a flat surface from vertical to vertical on the flat, and it makes this extreme point. So, and it can do amazing stuff. It can cut directly into end grain. It can roll beads backwards, which we need on the outside of a bowl. And it can form the lowest angle V in the world at 20, because a skew is already 40. And sure, I'll do that. 1 second. I'll move that out of the way. Will you be able to see it if I put it there? And it has a burr on each side, here and here from the grinding. And it needs to be quality steel. You wouldn't want to make it out of something because it does a lot of work, so it dulls really quick because that point is extreme. It's extremely pointy. Now, obviously it works pretty flat because we're going into here into a curve, so don't point it uphill because it'll just become aggressive. It won't grab, but it'll just become aggressive.
So here what I'm going to do, I'm going to form a V. It's going to cut in from one side, forming a V. From the other V, cut it out. So it's extremely pointy. I don't think I've quite got the grind on this right. No, I can feel it. I missed the grind right at the point. I can feel it. It's not cutting. So I'm just going to grind it one more time. It might have got knocked in the box on its way over. Yeah, it has. I can see the points damaged on it. So I think it's bumped into another tool when I was bringing it over. Yeah, it's not quite right. Sorry about that, but I got to sharpen it. Yeah, the point's gone. And it's relying on that point. That's why it wasn't slicing. Tiny bit more. Yeah, I punched up the point. There we go. Yeah, it's going to be hot. I'm heating up my tea with it. I can drink it again later. Oh, there it is. See the difference? Yeah, it was definitely the point had gone on it completely. So I'm going to be careful because this will go right through the side of the bowl if I'm not careful. So I'm cutting in a V from both sides. Nothing else will fit in here. You can't get a skew in here. The gouge won't fit. You can't get a scraper in there. And then I can cut backwards with that burr. For cutting backwards here, I can cut with that burr like there. So now I'm negative rake scraping on the way out with the burr. Now this tool doesn't remove a lot of bulk. It's a finesse tool. But it lets me work into the corner. And then going the other way. Gotta be careful going the other way because I've got a little bit of a gap between the tool rest and the bowl. I don't want the tool to go in that gap. And it gets me an extremely pointy corner.
Which you can't get there with sandpaper. Ooh, I think that's got it. Ooh, yeah, that's thin. Yep. I think I got it. So that bowl, yeah, I could have gone a little further around, but the bowl will go inside like that when I hollow it. So yeah, let's just move on. Okay, it's done. All right, so you don't need that tool again. We're done with it. Like I said, it does lots of little tricks. Next month, I'm going to make a video on what the tool can do. It's like working on end grain and beads on bowls. Because I've never actually done a video on how it works. So, what we want here is a tenon. Let's just do that with a skew. That'll be fast. And then we can spin it round. Okay, then we can hollow it out and then we'll jam chuck it because we're running out of time. Okay, so from here, we're just going to put it on the smallest chuck I've got here. So we're just going to put that'll be plenty to grip on. We'll hollow it out. So it doesn't weigh very much now, but it does need hollowing out, and we're already on the smallest jaws, so that should grip that. Location. That's why it's location first before we secure it to make sure it's running true. Let's start slow, check it's running true. Close enough. And now let's hollow it out. Now I'll need to use two gouges. So I developed the 40-40 gouge when I was a teenager, about 16. And then I realized that the 40-40 gouge is great on bowls, except for going across the bottom of a bowl. So when I started doing more bowls, I needed to develop a tool to go across the bottom of the bowl. And that's when I developed the bottom bowl gouge. Somebody I was chatting with earlier mentioned the bottom bowl gouge is like a roughing out gouge. It is actually a roughing out gouge. It is a roughing out gouge because it's ground straight across and it's meant for finishing side grain. And that's what roughing out gouges do. They finish side grain. That's my bell to let me know I've got 15 minutes, so I got to clock it a bit here.
Okay, so let's get this thing hollowed out. Oh, more speed. Okay, so this bowl gouge is going to need to go undercut. So let's get some of the guts out first. What have I got? Oh, not that much. Okay, so now I'm going to go undercut. So that thing's a little bit in the way. So when you go undercut, you're cutting technically incorrectly. Because you're working against the grain fibers.
So the tool needs to be sharp, and I picked up a brand new gouge, and then you need to cut slow without opening the flute very far. That's the problem with the Irish grind. That's why you can't get as good a finish on the inside. The Irish grind has got a 60-degree nose. How do you do an entry cut with a 60-degree nose? You can't. This is a pointy nose. It's very pointy. It's 40 degrees. And then also, I've got the flute closed, which means it's slicing through the side grain, finishing end grain, which means it's not tearing the grain. If you use an Irish grind, you would have to open the flute and have the gouge flute facing vertical like this, which would be tearing on that upper wing and possibly going to catch. So with a 40-40, it's the opposite. It's a slicing tool with a peeling action. And therefore, what it's able to do, it's able to
slice through the end grain and everything there and give me a good finish. So here I'm just going to get rid of more of the middle. Now it has its limitation. It doesn't like the bottom of the bowl. So in a minute, we'll go to the bottom bowl gouge.
Check the thickness one more time to see if I can cut it one more time. Oh, yeah. Can make that a bit thinner. Okay. And so it's not quite as thin as I'd like, but we're going to leave it as it is.
I'm going to go with one more cut down here. Oh, that is affecting my cut a little bit. If I'm hitting it. Oh, thank you. Yeah, there we go. Thank you. Let's come around the corner. Now, at some stage, this bowl gouge is about to hit the rim. Right there. That means it's bowl gouge. Thank you. That's got it.
This bowl gouge can't go any further. Perfect. That got it. Yeah, this bowl gouge can't go any further. So we go to a bottom bowl gouge. Here I've just got a Doug Thompson one. It's a design that I developed years ago for Jerry Glazer when I was in my 20s. And Doug Thompson copied it a few years ago. And it works great. This is just a U-shaped gouge. It could still be an elliptical gouge, but it wouldn't want to be a V gouge. It's just a simple U, and it works like a spindle roughing gouge, which are normally just U gouges, and it works across the bottom. The secret to this is not to grip it up here, it's to let the bevel do the work. So I'm using my left hand just to get it started on the cut, but then once I'm in the cut, I'm not using it as a fulcrum. Let's get the chips out before they build up too much. Let's get across the bottom. The bottom bowl gouge is extremely effective across the bottom when used correctly, but it mustn't touch your body. If it touches your body, this gouge will not work. It must be free to float and glide in on the bevel. If it touches your body, then it stops working, and then it creates ridges across the bottom and starts kicking because it's lost its bevel contact. So it's going a little deeper there. Notice I'm not using my left. It's just a weight. Just a weight, just a weight. This one's grounded about 60. I didn't measure it today. I actually freehand ground it 100% just to save time. One more cut. And then we'll reverse it and jam chuck it. It's equal all the way around, even though I'm only using the bottom half of the flute. So I don't actually use the top half of the flute, but this is not lopsided. No, it's just ground evenly on both sides. And here I'm cutting above center and finishing on center. So I don't cut through center, I cut down to center so that I don't jump past center. It's a very, very effective tool. I got a little bit of over rub of the bevel so I can see a spiral mark. So let's cut that out. So that meant that I pushed too hard with my palm. So I want a little less harmonics, so lighter with the cut. Lighter, less harmonics. I'm feeling to see if I got any vibration. I got a tiny bit there. I can feel it. See if I can cancel it. There, it's gone. So I slowed down till the vibration disappeared. I'm right at the limit of that gouge. You can hear it hit the side. So 60 degrees, I just made it. Never. No, if I push laterally, the gouge will kick because I'll push it off the bevel. And therefore, what would end up happening is it would 100% lose control. And I wouldn't be able to control it because I'm too far off the tool rest. I've given away my leverage. So it's just downward pressure. See if I can get to the center better this time. There we go. Not quite getting it. A little dark in there. I just feel like I'm over rubbing the bevel, but I think there's a little spiral in there. We're going to leave it. We're going to call it a decoration. Going to add an extra $100 for that. Okay, so that's just about done, all except I got to jam chuck it. So what have I got for a jam chuck? I've got one here somewhere. And will that fit? That. Yeah, there we go. So jam chucks, I just keep a bunch of scrap wood kicking around somewhere with a tenon or a recess on them. And then I just grab whatever one. I brought two with me. So if this one doesn't work, I've got another one. And I even brought a block of wood should I need to make a new one. The only problem with this, I've got to expand into there. So that was originally done with a 5-inch jaw set. And I think this is a 4-inch. But the nice thing about Vic Mark chucks is they just keep going. So you can keep expanding them way out and it'll still grip it, I think. We'll find out. Yeah, there we go. Oh, that's definitely going to crack now. It's not going anywhere. It's not heavy enough. If it was a big 30-pound block of wood, I'd reconsider and think maybe I won't chance it, but it weighs maybe 7 or 8 ounces. That's way too big, so let's just get rid of some of this meat. Let's block speed right up. Let's get going. What size is it? Put that there. So I'm just doing a taper for now. Okay, so it's the same size as the bowl, so I need to take off about the same thickness as that. I'm cutting it with a gouge, but I won't do the final fit with a gouge. I'll do that with negative rake scraping. The gouge will get me close, and it's faster, but the negative rake scraping will get me accuracy. Not quite fitting. I need to find out where it fits, and once it fits, that's the diameter I want to make in a parallel cut across the whole surface. So right now it's tapered, and then I find out where it fits that taper, and then I take that taper and I straighten it out. Okay, so it fits about a quarter from the top. So a quarter from the top, but I also want to give myself a shoulder to locate on, so I'm going to remove some of this material here that I don't need. Hopefully I got enough wood there for this, because there's a chuck in there somewhere. And that little beading and parting tool, it's got a burr on it from me sharpening with it before. So I'm going to use it to fit. It was about a quarter from the top. So I'm going to make about a quarter from the top parallel. That's what I'm going to fit on. Okay, going to take one more. So you're better off taking off less than more because you can't put it back. And I'd rather have a go, get close than miss it and then have to cut deeper in because I don't have a lot of spare wood here. God. Sometimes you can stretch the wood. No, that's more stretching than I want to do today. I don't want much though. If I take off more than just a tiny bit of powder, it will fail on me. Just there it is. That's all it needs. Just a tiny bit. It's amazing how much more you're taking off than you think. Oh, there, that'll go. So to get the fit, I got to take a few seconds to get there. Why am I taking a few seconds? What's happening? Yeah, it'll give a little bit. The amount of times where I've popped it up too quick and lost it, which is like awful. Because if you lose it, well, this is a really tight one. So this isn't going anywhere. I knew there was a use for this guy. All right. Of course, I can't remember how thick it is because I didn't measure it. So let's hope I don't blow it up. But I think I got plenty of wood. Okay, so just need one more cut and then it's done with the gouge. So don't need that much leverage. And like I said, on our website, we've got, I think there's a video where I'm making a square bowl, where there's a video of it. And there is at least maybe 30 videos there, techniques and tips and what have you. I'm going to take the bark off. I don't like it. It's just, yeah, it's kind of crummy. Yeah. I'll probably take it off after. But, ooh, why am I seeing daylight? Okay. That V cut went a lot deeper than you thought. All right.
Daylight's okay sometimes, but not where it is. Woo! All right, I was thinking I was Jimmy Clues for a minute there. We're not going to turn that fast. So we're just on 1200. I think we can move a little bit of the bottom here, and then we're going to push around. Now I'm pushing slowly here, and so I'm going to use the wing here a little bit because it's going to be less stressful. Thank you. A little less stressful on the piece. And then we'll push around. So I got to get rid of my chip mark. The one thing about the chip mark is with big mark jaws is they're just oxidized steel, so they will leave a black mark there. Now this cut needs to fade out before the top, but without a big step. And let's give it a quick negative rake. What do we got? I'm good, thank you. So we want to go the opposite way this time. Going to put a burr on the other side. We're a little bit low. And then we got it. Of course, we still got to get it off the chuck, of course. Will it reach it? Yeah, it'll make it just all the way close to the top. Yeah. That's where negative rake's really effective at blending the two surfaces from before. And it's very effective on oak. Oak really likes negative rake. Notice that I'm pointing it uphill a little bit because I'm not exactly on center. And let's see if we can get it off the jam chuck.
I'm pretty tight, so I'm thinking, ooh. Now, this way you can break it, getting off the jam chuck. So don't pull it by the wings, pull it from the side, because that way I'm going with the grain. There we go. Oh yeah, I like getting lucky. That's it. Yeah, so it came off okay. And yeah, it is a little thin in one spot, but it's just right where the vortex tool went through. It's pretty thin. Now, like I said, the vortex tool is going pretty deep. But you can see some black oxidizing on my hands on the bowl, but it's just a demo bowl. And I'll leave it for the club to decide what they want to do with it. And you guys can have a look at that. I think we got a minute for questions. Any questions? Any questions? Right. Because it's mainly end grain, and in this area here where I'm doing that curve here, the bond ball gouge might have been okay there, but because it's cutting upward, it's going to punch out the corner because it's cutting outwards. Whereas the negative rake is abrading away the surface, so it's not punching or doing anything like that. So that's the problem with the bottom bowl gouge. Also, it's generally a duller angle, so it's a little bit more pressure to cut, so the wings would put more pressure. So I was doing a combination of gouge and then getting it ready for the negative rake. Thanks. Any other questions? Right at the back. One thing I'm going to do, because right now, this grinder's noisy. I'm going to slow it down. Sorry about this. Slow down. Right, sorry. Just say it again. Well, I'm using the negative so it doesn't self-feed. The negative is what the negative does. It puts the burr on a different plane to the base of the tool, and that's what stops it interacting. Because the burr is not on a plane parallel to the base like a regular scraper, it prevents it from self-feeding. And we need the more acute angle to give us a bigger burr because that gives us longer time. That's what it's all about. That's why you want to use more exotic steels, coarser wheel, push in a little bit, uh, lower included angle. All of those add to a bigger burr, longer cutting time. There was a question. Great. But the only thing with Corian, yeah, I'm forgetting about Corian. I've turned Corian. It's super abrasive resistant. It's very abrasive. It'll be great for doing like finish, but I wouldn't do any shaping with it. Just for the simple reason, the problem with Corian I was turning some corian with somebody who was making chess pieces out of corian. He was using conventional carbide scrapers and then finishing with negative eight because he could cut for longer with the carbide, but then carbide doesn't make a burr. Then he used negative rake to finish it before he sanded it. So it would work okay, but the corian will dull off. So that's when you definitely need to make sure you're using at least 10V. So you're going to keep that burr longer. And for the corian, I would sharpen the burr on a finer grit wheel, 220, 300, just so I'm getting a finer burr because it's going to leave more of a witness mark than it would on wood. Yeah. 180 is good. You could go with 80. It'll give you a bigger burr for sure, but it'll also wear the tool out twice as fast. So you'll get a bigger burr. I wouldn't use 300 or less for negative rig. Tom Worsing does. He uses 300, even sometimes 600, but he's looking for something different on super highly figured maple. But then he's going to grind, he's sharpening way more times, probably 4 times as many as I am, because his burr's gone quicker than mine is. So the finer the grit, the less time you'll get with the burr. And you can also push into the wheel a little bit. That'll create a bigger burr, but then you're wearing out your tool faster. So everything's a little bit of a sacrifice for that bigger burr. Coarser wheel, bigger burr, more steel off. Pushing in the wheel, you're going to create a bigger burr, but you're going to wear down your tool quicker. That's why using better steels is better. M42 is not exotic, by the way, guys. I know everybody tells you exotic. M42 is not a great steel. I know everybody talks about it. It has a quarter of the life or maybe the fifth of the life of 15V. It has less than half the life of 10V. It has less than half the life of M4. You want M4 or you want 10V or just buy M2. We had a class where we taught recently where one of the guys had an M42 in the class. He was sharpening it all the time. He was like the guy at the grinder, like every cut. It's not meant for wood turning. It's meant for elevated high temperatures milling where they don't need a super fine edge. It's as simple as that. So M42 is not the greatest steel in the world.
What cases do you use?
I would use it to do a dovetail inside for a recess. It's very good for there. If I'm just looking to remove a lot of side grain quickly, it can be effective, especially in an enclosed space where I can't get a gouge. But otherwise, it's not a great finishing tool in general. And I would never use it on anything other than side grain effectively. Where it's dangerous is on end grain of exotics. It'll always feed, even if you take the burr off. Negative rake is incredibly effective inside a box. So if you're doing end grain boxes in exotics, dense woods, end grain, it will never grab. And it works it really well, and it'll finish it so you can start sanding at 320, especially on exotic woods. Negative rake's very effective on that. Any other questions? Was it? Negative rake on what's it? It would be very good. So anything that's dense, like Marty's saying, antler, acrylic impregnated woods, pen blanks, the denser the wood gets, the more effective negative rake gets. Woods that have been impregnated with cactus juice or acrylic, it's very effective. It works on certain plastics, but not all. Plastics are weird. Every plastic turns completely. If you ever turn in plastics, like Delrin works completely different to the medium density plastics, and every plastic is like a kind of wacky, different to everyone. I've never had great success working different plastics with negative rake. It's weird, but it works on wood that's impregnated with a plastic, with a polymer. then it works great. That's very different because the structure is still mainly wood. It's just plastic in between the pores. Any other questions? Yes. It could be small. It could just be a half-inch skew turned into one, something like that, as long as it's like a double angle. By the way, I forgot to mention, I'm teaching a class next week on the 13th, a 5-day class. If anybody's interested, I'm going to leave my business cards over here, or just go to stuartbatty.com. We do have spaces, 2 spaces. We had 2 people that had to pull out at the last minute. So there is a space for a 5-day class where you'll turn at least 20 to 25 bowls, because that's what you do, and you'll do spindle turning, pommel cuts, and end grain hollowing and end grain finishing. So we do that next week. It starts on the 13th. It's in Boulder, just outside the city limits of Boulder. We're on Arapahoe. We are running a class there next week. Most people are out of state, but we just had 2 people that couldn't make it next week, had to pull out. So there is a space, and Jess has done the class before. She's probably going to drop in, so that might leave us just 1 space. But if you are interested, see me later, or contact our number on our website. It's on there. Any other questions before we call it? Yes, I'm thinking of doing it September, October, November, later in the year. I'll speak to Jess about it because we do want to do that, but we're not there yet. We've only been in the building a year. We've set up a school. We set up a recording studio. We've got some CNCs in there, but we've got 3 more CNCs to go in March or April. Once we get those going, then we'll bring people in, and we'll probably do it as an all-day Saturday where I'll do live demos in the school. We'll push the lathes to one side, and then you can do a tour around the factory of what we're doing. We have some unique processes. There may be some processes we may not show. Just that our lamination technology is so advanced and so complex. It took decades to develop how we laminate very radically different steels together. That's what that big gouge that I sent around. It's an extremely high tensile steel brazed to a really ductile magnetic stainless steel, but the process of doing it that we developed was so complex. And we do cryogenic, but we don't heat treat in house and braze in house. We do the braze assembly in house, but we heat treat at a very good heat treat place in Berthoud, Colorado. We're very fortunate to have that heat treat because in Colorado, nearly all heat treating is done in 1 state over. Nearly everybody ships a heat treat out, but a new place started up, and the guys are fabulous, and they've really helped us develop our unique lamination process where we can laminate a super expensive, really radically expensive steel to a very cost-effective steel, letting us to make these new laminated chisels. Metalex Thermal Specialty. Metalex Thermal Specialty. They're really good. They have a big 1,000-pound vacuum furnace. They have another one coming online, and then they also have setting up an oil quench furnace. They do vacuum heat treating. There's another one in Longmont, but they have a tiny argon furnace. Anyway, not the same. Yeah. Anyway, any other questions? Otherwise, we're done for the night. Don't forget, we got to tidy up. I didn't make that too much of a mess, though. So thanks. Thank you.